All right, welcome to the deep dive. Today, we're going deep into AI agents,
Yeah.
specifically in software development. All the stuff you sent over really points to something. These AI systems, they're going way beyond like simple tools now.
Yeah, for sure. It's almost like they're turning into actual collaborators, like working with you on the code, testing, even, the whole project management side of things.
What's really blown me away is how these free tools and Google's Gemini API are making all this stuff accessible, like seriously cutting edge tech, and anyone can try it out.
That's the really exciting part. It's not just for the big players anymore.
So our mission, if you will, is to kind of break down what all this means. What are the biggest takeaways? And what does it mean for actual developers out there, whether you've been coding for years or you're just starting out and curious about this whole AI thing?
I think the biggest takeaway right off the bat is this. AI agents, they aren't some futuristic concept anymore. They're here, they're being used right now, and learning about them, understanding them, it can give you a serious advantage.
For sure.
Streamlining your work, being more efficient, maybe even opening up whole new ways to create software. That's what we're going to try to make clear today.
Absolutely. And we've got a good mix of stuff to dive into. Some pretty heavy research papers, industry articles showing what's trending right now, and even some how-to guides on actually using these AI agents and the tools behind them.
Should give us a pretty solid, well-rounded look at what's going on.
Okay, so first things first. One thing that really jumps out from all these sources is that AI is already making a huge impact in software development.
Absolutely. It's all about enhancing productivity, right? Making sure
Yeah.
code is top-notch and definitely speeding up the whole process of building and releasing software.
We're not just talking about typing faster here.
No, it's the entire life cycle, from start to finish, more efficient.
And we've seen some of this already in action, haven't we? Tools like ChatGPT and GitHub Copilot. The sources mention them a lot as these AI assistants that are changing the game. It's not just about suggesting code. They're actually changing the skills developers need.
It's subtle, but it's happening. Being a great developer is becoming less about, knowing every single code rule or writing everything from scratch. Now it's about working with these AI assistants, understanding their suggestions, figuring out when to trust them, and how to get the best results from them. You almost need to be AI literate now. That's becoming a core skill.
Yeah, I see that. And it's not just the initial coding either. All these sources talk about how AI is also automating the CI/CD pipeline, that continuous integration, continuous delivery stuff. Sounds like it could really take a load off developers.
Big time. Think about it. Instead of you manually kicking off builds, running those tests after every little code change, which honestly can be a bit tedious and you're bound to make mistakes sometimes, now AI tools are monitoring your code. They trigger the builds, they run the tests, they even deploy updates, like almost hands-free, makes the whole release process so much faster and smoother.
Okay, that's how AI is helping right now. But AI agents seem to be a whole different ballgame. What makes them stand out, in your opinion? What's the key difference?
Independence, that's the key. Tools like Copilot are amazing, super helpful, but they mostly react to what you tell them to do. AI agents, though, they can actually perceive their environment, like see what's happening in your code base, your project management tools, whatever.
Okay.
And then they can actually reason about that information and they take action, like real action, to get things done. They can basically figure out their own workflows and how to use the tools they've got to reach a goal. They don't need someone holding their hand every step of the way.
Here's where it gets really interesting. The sources talk about language agents being like crucial partners in creating software. That seems like a fundamental shift in how we work with computers.
Massive shift. We're not just telling the computer every little step anymore. Line by line, super specific instructions, language agents, you can talk to them, give them higher level goals, just like you would a coworker, and they figure out all the details.
Wow.
They're becoming collaborators, like genuinely working with you.
And this deep dive specifically, we're focusing on how to explore all this using free tools and Google's Gemini API.
Yeah.
Which is pretty amazing because Gemini has a free tier for trying things out.
Yeah, that's huge. Anyone can jump in and start playing with this technology. It's not locked behind some paywall. And with all these free and open source frameworks popping up for building AI agents, it really is democratizing access. You don't need a ton of money or some crazy powerful computer to get started.
Let's get a little more specific now. What's the latest research saying? What kind of cool advancements are we seeing with AI agents in software engineering?
Well, there's a lot of work being done on how AI can help with project management, which, let's be honest, can be a real pain sometimes. Imagine AI analyzing your project and flagging potential problem areas before they even happen,
That'd be amazing.
or predicting how much developer time you'll need, or even making the whole testing process more efficient and, less prone to errors.
And more accurate resource allocation, like
Yeah.
knowing when to bring in someone with specific skills for a particular task.
Exactly. It's about having an AI teammate who's got your back and can anticipate what's coming down the line. And it's not just about managing the project from a high level. Research is also showing that AI agents can directly improve the quality of the code itself
That makes sense.
and even help define those initial requirements for the software in a way that's clearer and less likely to be misinterpreted. This means less back and forth, less confusion, and ultimately better software. More reliable, fewer headaches down the line.
And those language agents we talked about before, they're really at the forefront of all this, aren't they? Automating coding tasks, offering suggestions while you're working, even helping with debugging, which can be a real-time sync.
Absolutely. What I find fascinating is the potential for AI to change how humans and computers actually interact during the development process. It's not about wrestling with complicated code or deciphering error messages. It's about talking to the AI, telling it what you want to achieve, and letting it handle the nitty-gritty details.
The sources also mentioned a really important trend, integrating those large language models, the LLMs, that generate code, with tools that analyze and check the code. So it's not just about speed, it's also about making sure the code is solid and doesn't introduce new problems.
That's absolutely key. While LLMs are incredible at generating code that looks and feels very human-like, there's always the question of, well, is it correct? Does it have bugs? Will it create security issues? So there's a lot of research focusing on combining LLMs with established tools for static analysis, code linters, and all those quality checks. It's about making sure the AI-powered development process is trustworthy and reliable.
Some really specific examples popped up too, like Devon. It's aiming to be a fully autonomous AI software engineer. Can you believe that? Handling bug fixes, adding new features all on its own, seems incredibly ambitious.
It is. Devon's goal is to take natural language instructions like fix this bug or implement this feature, and then just do it. Figure out the problem, write the code, test it, the whole 9 yards. If it works, that would be a huge step forward. True collaboration with AI.
There are other projects too, like Repair Agent, which is all about bug fixing, Auto Code Over, which tries to understand the intent behind software requirements to improve its work, and SWE Agent, which gives AI agents access to the standard tools that developers use. It's like they're getting their own tool belts.
It is fascinating to see these different approaches emerging, each with a slightly different focus. Repair Agent, laser-focused on fixing bugs, Autocode Rover trying to understand the why behind the code, and SWE Agent really aiming to integrate AI agents into existing development workflows by giving them access to familiar tools.
Then there's this agentless approach, the idea that we can achieve similar results just by giving really well-crafted prompts to these LLMs, instead of building whole separate agent systems. It's an interesting alternative for sure.
Very much so. It's asking, can we get the same level of sophistication by being really smart about how we interact with these LLMs? Instead of creating all these complex agent architectures with modules for planning and memory and all that, maybe we can guide the LLM to do what we want with really specific prompts. It could be a much more streamlined approach in certain situations.
Stepping back a bit, the sources mentioned these survey papers that are giving a big picture overview of LLM-based agents for software engineering. Seems like the field is maturing to the point where we need these kinds of summaries.
Definitely. These surveys are super valuable. They're categorizing all these different agents that are popping up, looking at the challenges they're designed to tackle and the different ways they're built. It's helping to bring some order to a very rapidly developing field.
The one survey proposed a framework based on perception, memory, and action. Which makes a lot of sense, right? How the agent takes in information, remembers things, and then acts on that information.
Yeah, it's a great lens to look through. You can analyze different agents and see where their strengths lie and where future research might be most impactful. And another survey talked about even more unified frameworks, not just for software engineering, but for understanding how autonomous agents work in general.
It feels like we're moving toward a more structured way of thinking about and building these systems. Okay, let's talk about the different types of agents that are being used in software development. The sources lay out a few categories, and it's interesting to see the range of complexity.
It's a whole spectrum, from super basic reflex agents that just react to what's happening right now based on fixed rules, to those sophisticated LLM-based agents that can reason, plan, and learn. You've got model-based agents, goal-based agents, utility-based agents, learning agents, all these different flavors of intelligence, each with its own pros and cons depending on what you need it to do.
And the sources also talk about autonomy levels, right? From simple processors that just do one specific task to these fully autonomous agents that can manage complex workflows on their own. It seems like the more autonomous an agent is, the more benefit they can offer, but also the more things you need to be careful about.
Exactly. More autonomy means they can handle more complex tasks without needing constant supervision. But it also means you need to be extra careful in designing them, testing them, and thinking about potential unintended consequences. There's definitely a balance to be struck.
Right now, it seems like the LLM-based agents are the most popular approach. They use those powerful language models as their brain, but then they have extra modules for things like memory, planning, and using external tools.
It makes sense. LLMs are so good at understanding and generating human language, and they can reason about complex concepts. It's a great foundation for building agents that can understand what we want and use the tools we've already got. Plus, the specific LLM you choose, like the ones available through the Gemini API, can make a big difference in how well the agent performs.
Let's get to some specific examples. One of the sources had a table listing different kinds of agents and how to build them using free tools and the Gemini API. First up, code generation agents.
Right. These agents can actually write code for you. You can use the Gemini API directly or frameworks like LangChain or AutoGen, which make working with these LLMs a lot easier. Imagine being able to automate all that repetitive boilerplate code, or describe an algorithm you need and have the agent write it for you, or even generate utility functions for common tasks. Saves you a ton of time and effort.
Next, code completion and suggestion agents. We've all seen GitHub Copilot, right? It has a free tier. And there's Codeium, also free. The sources also mention Gemini Code Assist as another free option.
Yeah, these are the agents that live in your IDE and just make coding smoother. They suggest completions as you type, help you avoid typos and syntax errors, and even suggest best practices based on your code. They're like a helpful pair of hands guiding you along.
Debugging and error detection agents. DeepCode AI is a free tool mentioned here. And using the Gemini API with existing IDE linters sounds like a powerful combo.
Definitely. These agents are all about finding those pesky bugs and vulnerabilities. They can analyze your code, looking for patterns and potential issues, and give you much more insightful feedback than traditional static analysis tools. Catching bugs early is always a good thing.
We also have testing agents. The sources mentioned using free frameworks like JNet and PyTest, and potentially using the Gemini API or AutoGen to actually generate test cases. That's pretty cool.
Automating testing is a huge time saver. Imagine not having to write all those test cases by hand. AI can create tests for you, potentially covering edge cases you might have missed, which means more robust and reliable software.
Documentation agents. Documentation is often seen as a chore, something that gets put off. These agents sound like a dream come true.
They are. Using NLP techniques with the Gemini API or free documentation generators like Sphinx and Doxygen, maybe even platforms like Diffy to make it all easier. It can automate so much of the documentation process, which frees up developers to focus on, actual coding. Plus, well-documented code is easier to understand and maintain.
Last but not least, project management assistance. Using the Gemini API with free tools like Trello and Asana to get insights into project progress and even automate some management tasks. Sounds like it could really help teams stay organized and collaborate better.
Absolutely. AI can help break down big projects into smaller chunks, figure out who should work on what based on their skills, track progress, and even handle some of the routine communication and reporting. It's like having a super organized project manager who's always on top of things.
Okay, so we've talked about types of agents and how free tools in Gemini can be used to build them. Now let's get under the hood a bit. What are the main components of these AI agents?
Well, most intelligent agents, whether they're used in software development or something else, have a few core components. Perception, which is how they gather and interpret information from their environment. Reasoning, which is how they process that information, make decisions, and plan actions. Action, which is how they actually interact with their environment to achieve their goals. And then, in some cases, learning, which is how they improve over time based on their experiences.
When we talk about LLM-based agents specifically, they often have things like a memory stream, a reflection module, and a planning module. How do these fit into the picture?
So the memory stream is basically a record of everything the agent has seen, done, and thought about in the past. The reflection module allows the agent to look back at this history, analyze its own behavior, and learn from it. And the planning module helps the agent set goals, figure out the steps to achieve those goals, and decide the best sequence of actions to take. In software development, these modules work together to let the agent understand tasks, remember relevant information from the project or previous interactions, and then execute the necessary steps using the available tools.
And of course, the LLM itself is the brain, right? The source of all that reasoning power and natural language processing magic. Since Gemini offers different models, choosing the right one for your agent seems pretty important.
It is. The LLM determines how well the agent understands instructions, writes code, and talks to other tools. The Gemini API offers a variety of models, each with different strengths and weaknesses. Some are better at complex reasoning, others have a larger context window for processing more information at once. Developers can choose the model that best fits their specific needs.
Then there's the whole area of tools and external integrations. That's how the agent actually connects to the real world of software development, right? Using APIs, accessing databases, that sort of thing.
Absolutely. Tools and integrations extended the agent's capabilities beyond just what the LLM knows. For software development, this could mean using specialized tools for analyzing code, running tests, manipulating code libraries, or even connecting to project management systems. And the function calling feature in the Gemini API is a game changer here. It lets agents seamlessly use external systems and data sources to get things done.
And finally, we have memory management. Seems like the agent needs to be able to remember things and keep track of context over time, especially if it's working on a complex task. Frameworks like LangGraph are specifically designed for this, right?
Yeah, memory is key. You need both short-term memory to keep track of the immediate context and long-term memory to recall information from previous interactions or tasks. Frameworks like LangGraph provide sophisticated ways to manage all this information flow and make sure the agent can actually use its past knowledge effectively.
So we've got our different types of agents, and we know the basic building blocks. But how do you actually build these things? What are the methodologies and frameworks that developers use?
Well, the general process usually starts with defining exactly what you want the agent to do. What's its purpose? What tasks will it handle? Once you have that, you choose the tools and frameworks that are best suited for the job. Then there's gathering and preparing data, designing the overall architecture of the agent, developing the core logic, testing and refining it, and finally deploying it and keeping an eye on how it performs in the real world.
The sources mention a few common design patterns, too. Things like reflection, which we talked about earlier, tool use, planning sequences of actions, and even building multi-agent systems. Yeah. The thought-action-observation cycle was a big one, especially for LLM-based agents.
These design patterns are really helpful. They're like blueprints for building sophisticated agents. The TAO cycle, it's about the agent thinking about the task, taking an action, observing the result, and then using that information to decide what to do next. It's a fundamental loop for many LLM-based agents.
Let's talk about some of these free frameworks that work well with the Gemini API.
Yeah.
LangChain and its extension, LangGraph, are popular Python libraries. What makes them so useful?
LangChain is a very modular and flexible framework. It's got pre-built components and abstractions that make working with LLMs, managing memory, using tools, and creating complex workflows much easier. LangGraph builds on that by letting you orchestrate all these components in a graph-like structure. It's really powerful for multi-step agent systems and applications with complex logic. And both are designed to work smoothly with LLMs like the ones you get through Gemini.
We also have Crew AI, another Python framework. This one's specifically for building collaborative role-playing agents. Sounds like a fun way to simulate how teams of developers might work together.
It is. You can define multiple AI agents, each with their own role, responsibilities, even personalities. Then you let them interact and work together to solve the problem. Kind of like a team of developers brainstorming and collaborating.
Microsoft has AutoGen, too. It's for building multi-agent systems and automating things like code generation and even model generation.
AutoGen is a very versatile and powerful framework. It makes building those conversational agents that can chat and collaborate much easier. It also helps automate parts of the development process itself, like generating code or fine-tuning machine learning models. And it plays well with Gemini.
Then we have Diffy. This one's interesting because it's more visual and no code or low code, so you don't need to be a Python expert to use it.
Yeah, Diffy is great for rapid prototyping, and for people who aren't comfortable writing a lot of code. It's got this visual interface where you can design workflows by dragging and dropping components. It makes building AI applications, especially ones that use LLMs like Gemini, much more accessible.
Rasa is another framework. It's known for building chatbots and conversational AI, but you can connect it to LLMs like Gemini to give it more power.
ROS's core focus is on those conversational interfaces, but you can plug in an LLM like Gemini to make it even smarter, so your chatbots can understand what users mean, access a vast knowledge base, and perform more complex tasks.
And finally, we have small agents, a more lightweight Python framework that's very code-focused, and N8N, which is a no-code tool for automating workflows. It even has built-in nodes for AI agents. Lots of different options to choose from.
It really is a diverse ecosystem. Whether you prefer to get your hands dirty with code or you want a more visual approach, there are tools for everyone. And that's what makes this field so exciting. The barrier to entry is getting lower, and anyone can start building AI agents with powerful LLMs like the ones in Gemini.
Now, there's a point about training these agents that I found interesting. It's not really about traditional machine learning training. It's more about prompt engineering and fine-tuning. Could you explain that a bit?
Sure, because these large language models, the LLMs, are already pre-trained on huge amounts of text and code, they come with a lot of knowledge baked in. They understand language, they can reason. So instead of training them from scratch, we often focus on crafting really good prompts. Basically, very specific instructions and examples that guide the model to do what we want. Sometimes, for really specific tasks, we might fine-tune the model on a smaller, more focused data set, but the core intelligence is already there.
So it's about using the existing knowledge in a smart way. Let's move on to some real-world examples. We talked about GitHub Copilot already. It's a great example of AI helping with coding in a very practical way.
Yeah, Copilot is super popular. It shows how seamlessly AI can be integrated into the development process and how much it can boost productivity.
There's also Uber using LangGraph to automatically generate unit tests, and Replit uses it for AI-powered code generation with human feedback and for setting up multi-agent systems. Those are some pretty advanced applications.
Absolutely. Those examples show how frameworks like LangGraph can be used to build really sophisticated agents that handle crucial tasks like testing and code generation, making the whole development process more efficient and collaborative.
And LinkedIn has their internal SQL bot, which was built with LangChain and LangGraph. It lets employees access data just by using natural language. So it's not just about code.
No, not at all. It's about making information more accessible. You don't need to be a SQL expert to get the data you need. You just talk to the bot. These frameworks can be applied to a wide range of problems.
The sources even had some hypothetical examples, using Gemini and free tools to build things like an AI-powered code reviewer, an intelligent issue triagger, and an automated documentation generator. All very practical and achievable, it seems.
Definitely achievable. Those examples show the potential for solving real-world development problems. Imagine having an AI that checks your code for bugs and style issues, automatically categorizes and assigns bug reports, and generates documentation for you. It would free up so much time and mental energy.
And there's a ton of resources out there for anyone who wants to learn more. The open source community is a goldmine. The GitHub Handbook, the Hugging Face Hub. There's so many examples and projects to explore.
Yeah, the open source community is fantastic. You can see how others are building AI agents with frameworks like LangChain, AutoGen, and Diffy. It's a great way to learn, get inspired, and find ready-made solutions that you can adapt for your own needs.
Let's talk about tools. Python seems to be the go-to language for AI agent development, mostly because it's got so many libraries and frameworks.
Python is definitely the most popular choice. It's got a great ecosystem for AI, machine learning, and natural language processing. It's also relatively easy to learn, and there's a huge community of developers who can help you out. Other languages like JavaScript, Java, and C++ have their place, but Python is a great starting point.
We've already mentioned a lot of the key free and open source libraries and frameworks. LangChain, CrewAI, AutoGen, Diffy. They all work really well with Gemini, which seems to be a big plus.
Definitely. That ease of integration with Gemini is a huge advantage. It means you can build sophisticated agents without needing to invest in expensive infrastructure or proprietary software.
UI libraries like Streamlit and Gradio were mentioned too. They make it easy to build simple web interfaces for your agents.
Yeah, those UI libraries are really helpful. They let you create a more user-friendly way to interact with your agents instead of just using the command line. It's great for demos and for making your agents more accessible to non-technical users.
And we're also seeing AI-powered IDEs and other tools that make development even smoother. VS Code with its free AI extensions, JetBrains IDEs with AI plugins, Cursor, Google AI Studio. There are so many options now.
These AI-enhanced tools are becoming more and more common. They can really boost your efficiency, give you real-time assistance, and make the whole development process a lot smoother. Google AI Studio is particularly great for beginners. It's a free, web-based environment specifically designed for experimenting with Gemini.
So we've covered the tools. What about the fundamental AI concepts and algorithms that developers should know?
You don't need to be an AI expert to get started with agents, but having a basic understanding of key concepts definitely helps. Things like machine learning, natural language processing, and deep learning. Understanding how those work gives you a good foundation.
And when we talk about agentic AI, what are the core principles? We keep hearing about autonomy, goal-directed behavior, perception, reasoning, action, and the thought-action-observation cycle.
Those are the key ingredients of agentic AI. Autonomy means the agent can act independently to achieve its goals. Goal-directed behavior means its actions are driven by a purpose. Perception is how it takes in information from its environment. Reasoning is how it processes that information and makes decisions. Action is how it interacts with the world. And the TAO cycle, as we've discussed, is that fundamental loop of thinking, acting, observing, and learning. Other concepts like planning and task decomposition are important too.
The sources even included a hands-on tutorial for building a simple code explanation agent using free tools in Gemini. Can you walk us through the basic steps?
Sure. First, you need to set up your development environment, make sure you have Python installed, and then use pip to install the Google AI Python library with the command pip install Google Generative AI. That library will let you talk to the Gemini API.
Then you need an API key, right? You can get a free one from Google AI Studio, and it's important to handle that key securely.
Definitely. The best practice is to set your API key as an environment variable. That way, it's not hard-coded into your code. Once you have that set up, you can start thinking about the basic architecture of your agent. For a simple code explanation agent, it's pretty straightforward. The agent takes in a code snippet, sends it to Gemini with the prompt asking for an explanation, and then Gemini generates the explanation as output.
So the main part of the code will be in Python. You use the Google Generative AI library to connect to Gemini using your API key. Then you create a Python function that takes the code snippet as input. Inside that function, you need to write a prompt that tells Gemini what to do.
Exactly. The prompt should be clear and concise. Something like, please explain this code snippet, and then you insert the actual code. You'd use the generate content method from the library to send this prompt and the code to Gemini.
And then Gemini will send back a response. Your code needs to handle that response, extract the explanation that Gemini generated, and display it somehow, usually by printing it to the console.
Yep. Once you have that basic implementation, you can start testing it out with different code snippets. Try different programming languages, see how well Gemini explains them. You might need to tweak your prompt to get better results.
And then you can start thinking about ways to improve the agent. Maybe let the user specify the programming language, integrate it with a code editor, or experiment with more advanced prompting techniques. There's so many possibilities.
Absolutely. Building an AI agent is an iterative process. You start with something simple, test it, refine it, and keep adding more features. It's a great way to learn and to see the potential of these technologies.
So, to wrap things up, what are the key takeaways from our deep dive today?
AI agents are here to stay, and they're going to revolutionize software development. They're already boosting productivity, helping us write better code, and automating a lot of the tedious tasks. And the best part is, you don't need a lot of resources to get started.
Free tools like the Gemini API and all those open source frameworks we talked about are making this technology accessible to everyone. Whether you're a seasoned developer or just starting out, you can start building AI agents today.
And there's a huge community of developers out there who are willing to help and share their knowledge. The resources are there, the tools are there, the potential is there. It's a really exciting time to be involved in software development.
Absolutely. But we also need to be mindful of the challenges, right? Making sure these agents are reliable, that the code they generate is trustworthy, and thinking about the ethical implications of all this.
Those are important considerations for sure. As these agents become more powerful and autonomous, we need to make sure we're using them responsibly and ethically.
And the field is still evolving rapidly. There's so much more to come in terms of how these agents manage memory, how they plan and execute complex tasks, and how they integrate with other systems. It's going to be fascinating to see what the future holds.
Definitely. The possibilities seem almost limitless.
So here's a final thought for our listeners. Given everything we've discussed today, how do you see yourself using AI agents in your own work? What problems could they help you solve? What new opportunities could they open up? We encourage you to explore those resources, experiment with Gemini and those free frameworks, and see where your imagination takes you. The future of software development is being written right now, and you can be a part of it.